Hey guys, Mr. T here. This is another video. This one is on the new topic, networks. Unlike many of the other topics, this is probably not a revision. Okay, this is probably something new for you. So, listening up. Hopefully I can help you through this. So networks are structures or drawings that are used to represent the physical connections or relationships between things that we're interested in or things of interest. The things of interest are represented by dots or points on the drawing, and the physical connections or relationships are represented by lines connecting the dots. So for example, the following network shows the friendships in a school choir. So this is a representation of the relationships, not physical connections like networks can be about, physical connections, actual things that are existing. This one is just about relationships, okay? So you're using a mathematical drawing, a representation for something that doesn't actually exist. So the things of interest here, the blue dots, are in this case the choir members, and the black lines between the dots indicate the relationships between them. In this case, we need to be very specific, they represent friendships. Because if we didn't specify that, that relationship could be a bad one. Like, they might be enemies if we didn't explain it. In this case, we are making clear that they're friendships. So this shows that Lisa is friends with Pam, Rob, and Jackson. And so she's got 3 friends there. Pam's not friends with anyone except Lisa, so she's a bit of a loner there. Rob is friends with Lisa, Lucy, Sylvie. Jackson's only friends with Lisa and Lucy. Kate is only friends with Lucy, so another bit of a loner over there, and Sylvie's only friends with Rob. So we have 2 people who are equally have equal numbers of friends here, Rob and Lisa, and you can get that. You can come to that conclusion just with this little drawing here. So network terminology. We've got a bunch of terminology because it's a new topic. We've got a bunch of words and terms to get through so that you can speak at the right level for this. So the points of a network are known as nodes or vertices. You're able to go from one node to another along the lines between them. If the lines have no specified direction, they're called edges. A network consisting completely of edges and nodes is undirected. So what do we have here? Nodes or vertex. This is an edge because they're not directed. So a network consisting completely of edges and nodes is undirected. So this is an undirected network. This particular example here. Now, if the lines between nodes have an arrowhead that specifies direction, they're known as arcs instead, so no longer edges. A network consisting completely of arcs and nodes is directed. So, node, vertex, all of the lines have arrowheads on them, so the sorry, not edge, they're arc. And so a network consisting completely of arcs and nodes is directed. So this is a directed network in this particular case here. Edges in an arc can be assigned a number called a weight. The weight can represent anything like cost, time, distance. However, the length of the arc's edges is not related to the weight. So once again, we got node, vertex, the blue dots. We have edges here, no arrowheads. However, they're all weighted as well. So one thing to note is that the length of the edges or the arcs has nothing to do with the weight that's given to them, because the weight can mean anything. Remember, a network doesn't necessarily mean cities and roads. It can mean absolutely anything. It would be in the question what it's telling you. This could be minutes from one place to another, or it could be distance from one place to another, or it could be the cost going from one place to another. You don't know until you've read the question, so don't think that the lines have to represent the weight. Obviously this line is longer than this one, yet this one has a weight of 3, this one has a weight of 8. Next term, a connected network is a network which is possible to travel to every node by following the edges and the arcs. If it's not possible to reach every node, the network is disconnected. So here you can go from one node on the end and you can go to any of the other nodes. So this is a connected network. Whereas here we've got two nodes connected here, but they're completely separate to these other four nodes. So this is a disconnected network because you can't travel to all the nodes along the edges or arcs. Next, a path is a connected sequence of edges or arcs connecting one node to another. So for example, if we went started from A and went A to E to B to C to D, finished there, the path would be A, E, B, C, and D. A circuit is a path that starts and ends at the same node, so slightly different here. What if we went started from A to E to D to C to B, and then back to A? A circuit means you've gone back to a particular node that you went on. So a circuit's only different in that you end up where you started. So this one went A, E, D, C, B, back to A. So connected there. That's what makes it a circuit and goes back to a similar node. Last, but certainly not least, is the idea of a spanning tree. It's a set of edges or arcs connecting all nodes of a network without any circuits. So if I was to draw this, that is not a spanning tree. Because it has to connect all the nodes, not all nodes connected. So that doesn't make a spanning tree. What if I drew this? Here, 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 and then back there. That is also not a spanning tree. Not a spanning tree contains a circuit. A spanning tree is a series of edges or arcs that connect them without joining back together. So, by process of elimination, by showing you these examples here, the only way that I could draw a spanning tree for this set of dots, well, actually there's multiple ways, but I'm going to draw what's been given in the book, is connect that, connect that, connect that, connect that, connect that. This is a spanning tree. All nodes connected, all underline, no circuits. And just to go over again how there's multiple ways of doing that. If I quickly drew another example there, there's easily other ways you could draw another spanning tree. That they're all connected, there's no circuits there. Just one other example just to show you is just to clear up the idea of a spanning tree is a way of connecting all the edges where there's no circuit. Connecting up all the nodes where there's no circuit. So this would also be a spanning tree. Connected all the nodes, haven't connected back to the same one at all. So that's a bit of terminology out of the way. That should help you out with the first series of exercises we need to do for this topic. And I will see you in the next video.